Now let's solve one more question. If f of x is equal to 5x plus 6 sin x upon 6x plus 5 sin x, where x is not equal to 0, is continuous at x equal to 0, then find the value of f of 0. Now from the definition of continuity, you know it very well that if given function f of x is continuous at a given point c, if and only the limit of the given function at the point x equal to c is equal to the value of the function at the point x equal to c. So given function will be continuous at the point x equal to 0 if and only limit x approaches 0, f of x is equal to f of 0. And now when x approaches 0, then that means x is very close to 0. You can say either slightly greater than 0 or slightly less than 0, but it is not equal to 0. Now as per definition of the given function, if x is not equal to 0, then in that case f of x is equal to 5x plus 6 sin x upon 6x plus 5 sin x. So now this equation can be also written as f of 0 is equal to limit x approaches 0, 5x plus 6 sin x upon 6x plus 5 sin x. And now let's calculate the value of this limit. And from the definitions of limits, we know it very well that limit x approaches 0, sin x upon x is equal to 1. But the given expression is not in the form of sin x upon x. So first we shall have to convert the given expression into some sin x upon x form, and for that we shall divide both numerator and the denominator by x. And if we divide both numerator and the denominator by x, then this limit can be also written as limit x approaches 0, 5 plus 6 into sin x upon x divided by 6 plus 5 into sin x upon x. And from the properties of limits, you know it very well that limit of sum of two function is equal to the sum of their individual limits. So this limit can be also written as 5 plus 6 into limit x approaches 0 sin x upon x divided by 6 plus 5 into limit x approaches 0 sin x upon x. And limit x approaches 0 sin x upon x is equal to 1. So that means f of 0 is equal to 5 plus 6 into 1 divided by 6 plus 5 into 1, and which is equal to 11 upon 11 or 1. So that means if f of x is equal to 5x plus 6 sin x upon 6x plus 5 sin x, where x is not equal to 0, is continuous at x equal to 0, then in that case f of 0 is equal to 1. Now let's solve one more question. Determine the value of constant k so that the function f of x given by f of x is equal to k into x square minus 3x, where x is less than 0 and f of x is equal to cos of x, where x is greater than or equal to 0, is a continuous function. Now, as per the definition of the given function f of x, if x is less than 0, then in that case f of x is equal to k into x square minus 3x. And when x is greater than or equal to 0, then in that case f of x is equal to cos of x. So that means the value of x, or the domain of the given function f of x, can be divided into three regions. In the first case, x is less than 0. In the second case, x is equal to 0. And in the third case, x is greater than 0. So now let's check the continuity of the given function f of x for all these cases. In the first case, x is less than 0. And when x is less than 0, then f of x is equal to k into x square minus 3x. Now k is a constant and x square minus 3x is a polynomial function. So that means k into x square minus 3kx is also a polynomial function. And now kx square minus 3kx is a polynomial function, and every polynomial function is a continuous function. So that means if x is less than 0, then in that case f of x is a continuous function. And now let's check whether f of x is continuous for x greater than 0. Now if x is greater than 0, then in that case f of x is equal to cos of x. And you have already learned in the previous episodes that the cosine function is a continuous function in its domain. That means for x greater than 0, f of x is a continuous function. So now we have proved that f of x is a continuous function for x less than 0 and for x greater than 0. And now let's check whether f of x is also continuous at the point x equal to 0. Now from the definition of continuity, you know it very well. A function is continuous at a point if and only the limit of the given function at that point is equal to the value of the given function at that point. Or in other words, limit x approaches 0, f of x is equal to f of 0. And what's the value of f0? Now f of 0 is equal to cos of 0 or 1. And now let's calculate its limits, and for that we shall have to calculate both its left hand limit and the right hand limit. Now let's first calculate its left hand limit. Now limit x approaches 0 from the left hand side, f of x is equal to, now when x is less than 0, then in that case f of x is equal to k into x square minus 3x. So left hand limit can be also written as limit x approaches 0, k into x square minus 3x, and which is equal to k into 0 minus 0, or k into 0, and which is equal to 0. And now let's calculate its right hand limit. And the right hand limit is limit x approaches 0 from the right hand side, f of x. And when x approaches 0 from the right hand side, then in that case f of x is equal to cos of x. So this limit can be also written as limit x approaches 0 from the right hand side, cos of x, and which is equal to cos of 0 or 1. Now at the point x equal to 0, its left hand limit is equal to 0 and the right hand limit is equal to 1. That means left hand limit is not equal to right hand limit, and which is a necessary condition for a function to be a continuous function. And that means the given function f of x is not continuous at x equal to 0, and which means there can be no value of constant k for which the given function f of x defined by k into xk minus 3x when x is less than 0 and f of x equal to cos x when x is greater than or equal to 0 is a continuous function.